All right, ladies and gentlemen, so we did 8.1, today we're going to do 8.2 and 8.3. Just as a heads up, I'm not feeling real well, so sorry about my voice. Sorry about my voice, and be patient with me today, please. So today we're going to do 8.2 and 8.3 is my goal, all right? So these are both about parallelograms. We talked about quadrilaterals, and quadrilaterals means how many sides? 4. Today we're going to talk about parallelograms, which is just a special type of quadrilateral. So the rest of the chapter is talking about special types of them. Parallelograms are the most basic kind, and then from this one we're going to get more specific. So after these sections we're going to talk about squares and rectangles and rhombuses, all right, rhombi, all right. So today you're going to do 8.2 and 8.3 hopefully. Review, we don't need to do that. We did a quiz on that where you guys are good at that. First thing I want to start with is what is a parallelogram? The definition. We're going to have 5 different properties today. This is property number 1. So please, whoa, that is really thick. I don't know how to change that on this one. Alright, so we're going to do 5 different properties. That's your first property. Both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. And that's actually the definition. And this only works for a quadrilateral. So it has to be a 4-sided figure where both pairs are parallel. A picture of a parallelogram, which you guys are probably used to by now. 4 sides. Alright, that doesn't look great. Four sides. The opposite sides mean the sides that are across from it. So this side would be parallel with this side. And this side will be parallel with this side. Those marks that I drew on there, remember, say that they're parallel. And they work just like the tick marks for congruent. We have 1 pair here, so we mark them with 1. My second pair, I mark them with 2. Okay? So that's the definition of parallelogram. Let's take a look at this applet and see if we can discover anything else. So here's my applet for a parallelogram. You notice that I can move the parallelogram around. So if I move it, notice how it still maintains the parallel sides. Everybody see how the AB side is parallel to the CD side? We cool with this? Notice also, and this is for future reference, a square, for example, is also technically a parallelogram. Alright? Same with a rectangle. Oops, wrong point. Same with a rectangle. A rectangle is still technically a parallelogram. It's just a special kind. Okay? Today we're just going to talk about basic parallelograms, though. So go back to my shape. I want you to try and notice a few things. So if I show you the angles, I realize it was maybe a bit small. Let me hit the lights for you. What do you notice about the angles? What do you notice about the angles? Stephanie? Sure, so angle A and angle C are, what did you say? Equal? What's our geometry word for equal? Congruent? What other ones? And is that just because this is a special case? Let's check it. Let's move it a little bit. Are they still equal? So do you think this is going to be equal no matter how I move this? Does it matter how I move it? No, they're always equal. So one simple way to say that is that the opposite angles are congruent. So opposite means across from. See how these are the farthest apart? Does that make sense? What do you notice about these two? B and A. If you add those together, what are you going to get? Oops. If you add those two together, A and B, what would you get? What is it? 180. 180. A and B together is 180. What about A and D? 180. What about D and C? 180. What about B and C? 180, and that's going to be another property we're going to talk about. Okay. A and C, not true, because these are going to be congruent. So these are opposite, remember. Okay, we're going to talk about both those in a second. What about their side lengths? Take a look at the side lengths. What do you notice? Which two? AD and BC, and the other set, AB and DC. And notice that those are true regardless of what the shape looks like, right? So I could say the opposite sides are congruent. And the last one, this one's a little harder to see. I draw the diagonals, which cut across it. What do you notice here? This one's a little harder to say. Anything? Let me move it. So what do you notice here? Excuse me? They do form 4 triangles, I agree. What about their distances? Does it cut it into 2 equal pieces? The 9, so, see the whole diagonal is from B to D, right? You see that this one cuts it in half? So it cuts it into 2 equal pieces. Do we have a word for that? Cuts it in half? Bisect literally means to cut into 2 pieces. So we can say that the diagonals bisect each other. Notice how this one's cut into 2 equal pieces, but also these two are cut into 2 equal pieces. So it doesn't matter, okay? It could cut both ways. All right, back to our notes here. So we have the definition, that's step 1. And here are the 2 that we just saw. So this is 2, this is 3, and for each one I want you to draw a picture. For each one I want you to draw a picture. Make sure you get those properties down. Then draw a parallelogram for each one. How do we mark congruent sides? What do we need to put on them? How do I say that a side is congruent? Yeah, tick marks. So opposite means across from or furthest away from. So this side would be congruent to left, right, or bottom? Bottom. And then my second pair, this side is going to be congruent to the only one left on the right. Does this make sense? Opposite means across from each other. Am I going too fast? Our second one is about the angles. So this angle will be congruent to which other one? So across from is the opposite, so it's the furthest away, so it's going to be equal to the other acute one. Notice that they're both acute. And then my 2 obtuse angles will be equal to each other. And that's what we saw from the applet online. Any questions with those 2? So that's, we got 3 properties down. We have 2 more. Oh, we'll do some practice first, actually. So here's a problem. Is that figure a parallelogram? Why? So it could be 4-sided, but for example, can I draw a 4-sided figure that's not a parallelogram? Yeah, so it's got to be more specific. Well, what was the definition of a parallelogram? It was back here. Even simpler. Both pairs of opposite sides are parallel. That's why it's called a parallelogram. If you take a look at my picture, see the red arrows? That tells me that they're both parallel. So what do I know about 65 and y? They're congruent. So if that one's 65, what does y have to be? 65. And what do I know about the sides AB and BC? They're congruent because they're opposite, right? So this is congruent to this one. So we can say then, what should I write for my equation? Equals 12, because they're equal to each other. Subtract 4 on both sides. So x equals 8. Easy enough? Okay. One more? Do that one real quickly. Yeah, 1 minute. Somebody got the x done? Henry? X equals 25. How did you figure that out? Okay, which two are congruent? Which angles? J and L are congruent since they're opposite. So Henry did it in his head, which is fine. He just said 2x is equal to 50, and then he divided by half. Or divided by 2, excuse me. The other one, what would my equation be? Y plus 3 equals 18. So what does y equal, Cindy? $15. And that's because we know that the opposite sides are congruent again. Okay. So 3 properties we've done so far. The first property was what? Both pairs of opposite sides are parallel. What was property 2?
Opposite sides are congruent.
What was it, property 3?
Opposite angles are congruent.
Okay, so we talked about those 3. Those are the easy ones. Slightly harder are 4 and 5. These are the last 2 for parallelograms, 4 and 5. Consecutive angles are supplementary. Well, before we start, let's talk about what supplementary means. What does supplementary mean? No, that's complementary. It's the other one. Yeah, so they add up to 180 degrees. And what does consecutive mean? When I say that 3, 4, 5, 6 are consecutive numbers? In a row or next to. So consecutive means next to. So draw your parallelogram. We're going to have to name it this time. A, B, C, D. Make sure you put the arrows on it so you know it's a parallelogram. I don't know. Yeah, the next one. Okay. So consecutive angles. Name 2 that would be consecutive here, or in a row. Which one? BC would be fine. So angle B plus angle C then would equal what? 180. So consecutive angles, she said B and C were next to each other. So you add them up together, how much do they equal? 180. Another example? Just give me one more. BA, so angle B plus angle A is equal to 180 degrees. That's fine. We can do 2 more as well, okay? I'm not going to write them down. But just as long as they're next to each other. Is that okay with everyone? Questions? Okay. Last one. Diagonals bisect each other. Make this one pretty big because we're going to have to draw the diagonals. So there's my parallelogram. Draw your diagonals. So the diagonals across. Okay? And they bisect each other. They bisect each other. So that means that this portion of the diagonal will be equal to the other portion. However, it does not equal the other two sides. So you have two different sets, okay? They're not all equal. You just have two different sets. But this piece is equal to this piece. Okay? So they're not all equal to each other. However, you do have the half is equal to the other half. Does this make sense? Okay. I probably should have also said that this is a parallelogram. Any questions? Okay. So those are our 5 properties. Find all the missing angles. Find all the missing angles. So just go 30 seconds, real quick. This is a parallelogram. Sorry, I should have told you that. Who's got an answer for me? Bethany? Give me one of them, please. Angle Z is 119. How'd you know? Which angles? The opposite angles are congruent. So she said that Z is going to be congruent to X, which is perfectly correct. So we got 119. What is the other ones then? Cleo? Change your mind? Ryan? 61 degrees. Are they both 61? Yeah, because remember, these are congruent too. So W is going to be equal to Y. How did you get 61, Ryan?
They add up to 180.
What do you mean by they?
119 and 61.
Okay, so 119 degrees plus 61 degrees is equal to 180. And we know it has to equal 180 because these two angles are next to each other. So therefore, they are consecutive. Any questions? Easy enough? All right, this one's a little hard. I want you to spend about 2 minutes trying to figure it out, and then I'll help you out. Just so it's a little confusing. The 85 is right here. The 60 is right here. And the 45 is right there. I want you to find all the measures. So to help you out, to make it a little less confusing, I'll number them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So do as many as you possibly can, and then we get stuck, we'll go over it, okay? Do as many as you possibly can. Some are going to be very easy to find, some are going to be a little trickier. A lot of this is review from old stuff. If anyone would like to take their quiz during break, you're welcome to. Ten more seconds, don't start the whole one together. All right, who has anything? Who's got? Doesn't matter what number you want to go. It doesn't matter. Julio? Number 1 is what? 60 degrees. How do you know? What's that called if they're across from each other? And I remember what that's called? Vertical angles. So see the X here in the middle? We know that these two are across from each other, so therefore that they have to be vertical angles. Any other ones we know? Or did we get stuck right away? Henry? 5 is 45. I disagree. One of them's 45, but it's not 5. Let's look at 2 and 3 first. Does anybody have 2 or 3? So if I draw this line, how many degrees are in a straight line? 180. So we know that this is 60, right? So what does 3 have to be? If it altogether has to be 180? 120. Because 120 plus 60 will give me that full 180. Sorry, that should have been 3. But we also know that 3 and 2 are the same because they're across from one another. Everybody see 3 and 2? They're vertical angles. So 4, now this is where it gets a little tricky. So now we can figure out 5 because we know that 2 is 120, right? We know 2 is 120. We know that this is 45 degrees. How many degrees are there total in a triangle? 180. So can we figure out 5 from this bottom triangle then? Not quite. So we got 2 is 120. And we also have 45. So that adds up to 165. There's 180 degrees total. So it's 15. So 5 is going to be 15 degrees. We can do the same type of process to find number 4. Find number 4. So we know 1, right? What's 1? So we have 60. And we have 85 for the triangle on the left. So those add up to 145. So what does that mean angle 4 has to be? 35. Now here's the hard part. It's going to get a little complicated. So let me erase this real quick. It's 1, 2, 3. I'm going to extend these lines here. And these lines are parallel to each other. Okay, this is a parallelogram, right? Everybody agree with that? What's this line called then here, this red one, if it cuts across the parallel lines? Now, bisector had to cut it into 2 equal parts. We have a different name for this. Transversal. Very, very close, Jasmine. Transversal. And remember we had those 4 steps. We had consecutive, we had corresponding, we had alternate interior and alternate exterior. Take a look at number 5 and number 6. What relationship would those two have to each other? What relationship would they have? Alternate. They're on the inside of the parallel lines, so that's interior. You see how they're smushed in between? See how they're both inside the blue? So it's alternate interior. What do we know about alternate interior angles? They're congruent. They are on opposites, but they're congruent. So we know if 5 is 15 degrees, what's 6 going to be? 15 degrees. Angle 7. What's angle 7 going to be the same as?
4.
Angle 4. So what's that going to be? 35 degrees. Angle 8. What's angle 8 going to be the same as then? What is it? 45. And angle 9? 85. So once we got that first one, you use the same process and you use your alternate interior. Notice that they're, for example, 8 and 45 are on opposite sides of that transversal. Does this make sense? So we're just using the properties we learned a long, long time ago. Any questions with this one before we move on? How could you check your answer? You could always add up each one of these angles, for example, 3, 6, and 8, and make sure that they equal 180 for the triangle. Last part, what are those blue lines called? What are the blue lines called there? Diagonals. They're not bisectors necessarily. And what are they? They both bisect each other. I guess they are bisectors in this case. So if I mark this, the 16 is going to be congruent to which one? Which one?
4M.
4M. And this one's going to be congruent to 2N. Set up your equations. So we know that those two are equal. So what's the green one going to be? 4M equals, good. What's the red? 2N equals, oh shoot. Red is 2N equals, and then we just solve those. So let's do the red one first. I'm going to add N to both sides. These cancel because you have a minus N plus N. So you get 2N plus 1 is 3N equals 9. So N equals 3. And on the other side, what do I need to divide by? 4. So M equals 4. If I wanted to find the whole diagonal, the whole thing. So if let's say I wanted to find this whole thing, I could do it two ways. One is I could plug my answer back in over here. Or I could just find the 16 and multiply it by. Or I could do the 16 and multiply it by how many times?
4.
Not 4, because M isn't 16, M is 4. How many pieces are there? This is how much of it? How many? 2. So I could just take the 16 times 2. So the whole thing would be 32. Remember, bisect means cut into 2 even pieces. So if you know half of it, we can find the whole thing. How long is the other one then? How long would the other one be? 18. How'd you get that, Ryan?
9 by 2.
9 by 2, but it's not 9, it's 9 minus N. So what's N here?
3.
3. So what's 9 minus 3?
6.
6. Then you can multiply 6 by 2.
6 times 12.
12. Okay? If you look at the other half, 2 times 3 is?
6.
So you see how they're both 6s? So together they would be 12. Okay, either way you can do it. Alright, please write down your homework for this section. Right here. That's a picture of a solar flare, which we were talking about the other day. So we talked about solar flares when the sun basically explodes on the surface. It gives off a lot of electromagnetic energy. That's what it looks like. And we're going to do the next section too, so don't put your stuff away. So 3 to 4, 7, 8, 9, 10, 13, 14. So 2, 4, 6, 8 problems. They're all very, very short. One of them's a little bit longer, I think, but most of them are very short. Any questions on this lesson? So what are the 5 properties of parallelograms? Give me one per person. Number 1. Who's got them? Jasmine, give me number 1. Both sides of opposite sides are parallel. Number 2. Opposite sides are congruent. Number 3. Opposite angles are congruent. Number 4, Luis. Consecutive angles are supplementary. What does consecutive mean? Next to. What does supplementary add up to? And what's the last property we learned? Diagonals bisect each other. What does bisect mean? Cut into 2 equal pieces. Okay. We already got this written down? All right. And we're going to start this one. So 8.3, this is the opposite. So earlier we said, okay, this is the parallelogram, here are the properties. Now we're going to say, okay, I have this picture. How can you tell me that it's a parallelogram? So it's the opposite, it's the converse. So we're going to, it's very similar to the other section, just some slight differences. So how do we know if a picture is a or a parallelogram? It has to have 4 sides, and then we have to find out some other stuff about it. I realize this is a lot today, but they're very similar, and I don't want to spend a full day on the other stuff. You get to be bored out of your minds. Maybe you are right now, sorry. Can I move on? Cindy?
Yeah.
Okay. So name the 5 properties. We actually just did that, so we don't need to worry about that right now. Here are your properties written out. So if you see the list on the left, that's all the things we just talked about, right? If you see the list on the right, this is how we can prove, if I'm giving you a shape, whether or not it's a parallelogram. Okay? Notice that they're almost the exact same as each other. So if I give you a quadrilateral, has how many sides?
4.
If I tell you that both pairs of opposite sides are parallel, well then I know it's a parallelogram, right? If I tell you that both pairs of opposite sides are congruent, then I know it's a parallelogram. Okay, see how they're the same thing from left to right? The only one that's really different is this 4th one. We had consecutive angles are supplementary before. Now we have one pair of opposite sides are both congruent and parallel. One pair of opposite sides are both congruent and parallel. So what that would look like, I'm going to draw a picture over right in the middle. I don't know why my marker is small now. All right. So one pair of opposite sides are both going to be congruent. So they need to have the tick mark and parallel. That's that one right there. All the other ones are exactly what we did before. Does that make sense? I would only write the one I highlighted right there. So I'd write down the one I highlighted. No, just the right side. So do you see why I did these together? This section usually has a lot of proofs in it, but we don't do too many proofs, so that's why it's going to be so short, kind of silly. So I wanted to combine it with the other one. Can I move on? Oh, sorry. Can we move on? So the only thing that's hard about these is they're worded a little differently. So for what value of x is quadrilateral CDEF? You name them when you have 4. You just have to name them in order. So walk around the figure. So for what value of x is quadrilateral CDEF a parallelogram? Well, go back to our list. What have I given you? Have I given you any angles? Have I given you any of the sides of the parallelogram? No. What are those called, the blue things? What are the blue lines called? Diagonals. So go back, and it says, show that the diagonals bisect each other. Okay? So if we go forward, we need to make sure that they bisect each other. We'll take a look at these two. Do those bisect each other already, given by that symbol? Yeah. We know that those two are equal. So now, in order to make sure that they're equal, we need to make sure that these two pieces are also equal. Okay? In order to make sure that the diagonals both bisect each other. So all we need to do is set up an equation. What would my equation be then? 3x plus 5x minus 8? Oh, equals. Good. So they have to be equal to each other because they have to bisect each other. Does that make sense there? How would I solve this? How would I solve this? Luis wants to subtract 3x. You want to subtract 5x. It really doesn't matter. We can do whatever you want, so long as you are consistent. I'm going to do subtract 3x because a lot of people mess this up. You could subtract 5x. I'm going to subtract 3x. I get a 3 minus 3, so what do I get left? 0. Please remember to put the 0 there. A lot of people just forget about that, and they magically move the equal sign. Equals, bring it down right below it, and then 5x minus 8. Oh, sorry. Thank you. This is minus 3x over here, too. So I get 2x minus 8. A lot of people somehow move this equal sign in between the 2x and the 8. They just magically move it. Okay? What? In this problem, it would actually work out that way. It just happens to be that way. But it will not all the time. And then I want to get the 2x by itself, so what do I need to move? Plus 8. 0 plus 8 is? So 8 equals 2x, so therefore x equals 4. And if we check that, plug it back in, 5 times 4? Minus 8?
12.
This side's 12. What's 3 times 4?
5.
Are those two equal? So do the diagonals bisect each other? So then can we say it's a parallelogram? Yeah. Check. That's all we got to do. So it's very similar to the problems we just did in the last lesson, right? It's almost identical. They're just worded a little differently. Now this one is going to be hard. All right? Show that the quadrilateral is a parallelogram. Okay, let's go look at our properties. So we have a quadrilateral graphed on the coordinate plane. Okay? Let's go look at our properties. Property 1. Both pairs of opposite sides are parallel. Could we show that? Probably. Both pairs of opposite sides are congruent. Could we find the distance for each one of those? Using the distance formula? Yes? A review of long stuff time ago. Both pairs of opposite angles are congruent. Do we know anything about the angles? No. So we're definitely not going to use this. We could do the sides again. And then the last one, do we know anything about the diagonals? Anything about the diagonals? No, so we're not going to use this one either. So the question is, we can do any of those. Any of those. I think the easiest one's going to be this one. Both pairs of opposite sides are parallel. Because if they're both parallel, we know it's a parallelogram, right? So let's go back. How do I show if two lines are parallel? This is from chapter 3, a long time ago. We know something about their slopes. So we had parallel and perpendicular, right? What do we know about the slopes of parallel lines? They're not congruent though here. They're the same. Okay? So parallel lines have equal or the same slope. What about perpendicular? Opposite, reciprocal. Opposite, reciprocal. Okay? I realize this is a long problem. So we have to compare, we want to compare AB with which other one? What's the one that we want to look for to see if it's parallel to it? DC. And we want to compare which other two? AD and BC. Okay, does this make sense? Yes, no? You guys dead today? I noticed. Alright, welcome back. What's my formula for slope? Right up here in the blue. Can you guys see that? That looks pretty sweet. That looks good up there, doesn't it? M equals, what's my formula for the slope? What is it? Rise over run? Is perfectly correct. What about with x's and y's? y2 minus y1 over x2 minus x1. Okay? y2 minus y1 over x2 minus x1. So let's do AB first. We're going to have a lot of math here, so please write this down, guys. AB first. The last problem for today. So the slope of AB is y2. So let's do this one as x1, y1. This is x2, y2. Everyone okay with that? So M is equal to AB. What's y2? 2, nope. y2? 5 minus 3 over 2 minus negative 3. So this is going to be 5 minus 3, 2 over 2 minus negative 3. Yep, add the opposite. So this becomes add the opposite. So it's 2/5. Are we okay with that? I'm going to do these fast because we're running out of time here. Now we got to do DC. So for DC, this is x1, y1, and this is x2, y2. This one's going to be super easy. M is equal to, what's y2? 2 minus, what's y1? Over x minus 0, 2/5. So what can we say about these two lines? Not congruent. Their slopes are equal, so they are parallel. So these two are parallel. So we've got one. Does that make sense how we did that? Now let's erase these. And we're going to do it again for the bottom. So we'll do AD. I'll do, I'm going to pick x1 down here. It really doesn't matter. It's just going to make it easier for us. x1, y1. x2, y2. So for AD, M is equal to, y2 is 3 minus 0 over what's x2? Negative 3 minus, gives me 3 over negative 3. Can I simplify that? It equals negative 1. Is that okay with everybody? And then the last one, I'll do it in green again. We'll call this x1, y1. And what are these going to be? X2, Y2. So BC then, slope is, what's Y2? Minus Y1 over 5 minus 2. 2 minus 5? Negative 3 over, reduces 2. So what can we say about those two? Parallel. So we can mark them. Now we have two sets of opposite sides that are parallel. Is that the definition of parallelogram? Yeah. So is this a parallelogram? Yes. Do you see how we proved it? Okay. There's another way we could have done it if you wanted to. So notice we used the top one. We also could have said that both pairs of opposite sides are congruent. So you could have done A, B, and DC, and you could have found the distance for both of them using the distance formula to show that they're the same length. And then you could have done the same thing for the last two, AD and BC. So you could prove that the distances were equal. That's another way to do it. Or the combo. You could do one pair, but you have to show that they're both parallel and congruent. So in that case, you could have done just the top one. You could have done the parallel lines, and then you also could have found the distance for the top one, okay? So go back to your properties and make sure you just choose one of them. I think the slopes are always going to be the easiest because you avoid the square roots and all that sort of stuff with the distance formula. Do you remember the distance formula? Maybe I'll write it up here just for, it's D is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. Oh, I'm not a root. Squared. Alright? So if you need to, you can use that as well. I think the slopes are going to be easiest to find. Does everyone follow that concept there? Okay. It's just, you have to do it 4 times, but they're not too bad. Your homework for this section, let me check it real quick. By the way, that's my iPod. I have that one. No, that's not true. I have one that's slightly newer, but not much. Isn't that nuts? Look at how big that is. And that was like 2 Gs. What are they now? They're like 20 G on like a little tiny thing. 32? Okay, sorry. Apparently I'm behind. All right, thank you, Steve Jobs. You know he never went to college? Well, he did, but he dropped out. Steve Jobs dropped out of college. He's the founder of Apple. He just died. He had colon cancer, I believe. Or no, pancreatic cancer. Yeah. So your homework, let me take a look at it real quick. Yep, it's added to it. 3, definitely. 8 through 10, definitely. 19 through 21, definitely. And then let's just do one of these. I'll cut it. So this is number 11. It's going to be one of these problems. They don't give you a picture though, so you may have to sketch it yourself, okay? And this is a circled problem, so this means that the answers are in the book. So if you need to look at that, the answer's in the book. So yes, all this in addition. They're very, very short problems, like 2-liners. Before you leave, the Georgetown tutors are here every Wednesday and Thursday. Yesterday there were a number of them. There were more tutors than there were students. And it makes us look very bad. All right? I understand that everybody wants my help because I know more of what's going on, and it may take them a little while to get kind of the feel for it. But especially for geometry and the stuff we're doing, if you give them a brief explanation of what you need to do, they can definitely help you with it, okay? So I really encourage you today after school to come by. They'll be here starting around 4 or so because it takes them a little while to get here. please use this opportunity. I always feel awkward when it's me and like 4 tutors. I don't need the help, okay? At least I hope not. So please make use of that opportunity. Even if you just want to come and do your homework, they can just sit next to you and check it and make sure it's right and help you out when you get stuck. The other thing I want to mention is in college, when you go to college, using resources like tutors is going to be very valuable. A lot of students will come, but they don't want a tutor because they want to work with me. That's fine, but you have to realize when you go to college, very rarely is that the case. You'll have study sessions. You'll have to learn to work with other people who aren't the teacher, okay? Now, I realize this isn't college yet, but it's a little practice. So I know it's going to be a little awkward to work with someone you don't really know, but they're here to help you out, so please use that resource, okay? I want them to feel like that it's worth it to them. If they're doing that, it's a goodness of their heart, so please allow them to help you, right? Excuse me? They've had a partnership. I think they started 2 years ago, and so every year they keep sending over. I mean, I think there's 20 people who tutor, and so maybe not all of them come every week, but usually there's at least 5 people here every Wednesday and Thursday. So they come all the way over from Georgetown in rush hour traffic to be here. So I don't want them to make them sick. You know, that's not why they're here. Thank you for working with me today. Your homework is a bit much in terms of problems. However, they're all very short. Okay. The last one's going to be your long one. Questions before you go? Tomorrow we're going to cover a pretty challenging section, so make sure you're ready to go. Right? Wake up for your other teachers, okay? Adios. Back up.